video, we'll discuss sections 4.4, 4.5, and 4.6 on exponents and polynomials. Section 4.4 was focusing on multiplying polynomials. Multiplying a monomial by a polynomial. We use the distributive property to multiply a monomial by a polynomial. Remember, the distributive property states that for real numbers a, b, and c, a times the quantity b plus c, we would distribute the a and multiply it by both values inside the parentheses, a times b plus a times c. Here is an example. Multiply the number on the outside the parentheses into every single term on the inside the parentheses. The first one's multiplying 3 times c minus 3 times 4, and the second one we would multiply 2x cubed times x squared minus 2x cubed times x multiplied 2x cubed times positive 2. Keep in mind the signs go with the values. So in this center case, we are multiplying 2x cubed times a negative x, since the sign in front of the x was negative, while the other two terms were positive. Multiplying two binomials, the distributive property is used again, so that every term in one polynomial is multiplied by every term in the other polynomial. Here's an example. A lot of times we can refer to this multiplied method as the FOIL method you might have learned. FOIL standing for first, outside, inside, and last. Here's an example using the FOIL method. First stands for multiply the first terms in each of the parentheses together. In this case, the first terms are a times c. O in FOIL stands for outside or outer. Multiply the outer terms. So that would be the one furthest on the left times the one furthest on the right. In this case, it's a times d. I stands for inner. So the two terms that are closest together on the inside of our parentheses that are touching would be b times c. And L standing for last, we're multiplying the last terms in each of the parentheses together. In this case would be b times d. So the product of two binomials would then be equivalent to saying a times c first plus a times d outer plus b times c inner plus b times d last. Here's an example using numbers and correlating that with our FOIL method. Identifying our first terms are 7x times 2x, giving us 14x. Our outer terms are 7x times 4, giving us 24x. Our inner terms are 3 times 2x, giving us 6x. And our last terms are 3 times 4, giving us 12. And we can combine our like terms of 28x plus 6x, giving us a total of 34x. Here's a separate example using the FOIL method. Multiplying our first terms, 3x times 5x, our outside terms, 3x times negative y, our inside terms, 4 times 5x, and our last terms, 4 times negative y. Combining like terms, in this case we have none because x squared is not the same as xy, which is also not the same as x or y individually. So we can keep everything separately as 4 separate terms. Here's just another example using the FOIL method, but in this case the FOIL is removed and we are just showing the steps to solve. So how can this relate to everyday situations? When we're talking about widths or lengths, and the width of a living room, for example, is x plus 4 feet, the length of the room is 3x plus 5 feet. What is the area of the room? And we know area is length times width, so we can multiply these two values together to get that there are 3x squared plus 17x plus 20 square feet in the room. normally we would measure and actually find a total length and a total width, and we would not be working with variables. But this is just a case to show you that when we're multiplying two values together is very similar to multiplying two whole numbers together, except in this case we are using variables or numbers that are unknown. Section 4.5 deals with multiplication in special cases. Multiplying binomials, a sum and a difference. So if we have two values or two separate parentheses here, and these are binomials because we have two terms inside each, a plus b is in one and a minus b, the shortcut method is to say this is the same as saying a squared minus b squared. And you don't have to go through the FOIL method, because if you did, you would end up with a simplified version, which would say a squared minus b squared. So if you memorize this, it can make solving many problems easier and faster. Here's an example. 2x plus 4 times 2x minus 4. So this is our a plus b times a minus b. Our first term is 2x, and our second term is 4. So if we look back at our formula, we would say a squared minus b squared. So that would be 2x squared minus 4 squared. 2x squared gives us 4x squared, because we would raise both the 2 and the x to the second power, and negative 4 squared would equal 16. Here again we have a positive value, a plus b, a minus b. A squared, 5x squared, minus 3 squared gives us 25a minus 9. And in the second example, our first term of a is the same as 8c, so 8c squared. Our second term b, 2d squared, and we can simplify that to say 4d squared and 64c squared. A squared minus b squared. A second shortcut method is called the binomial squared. A binomial squared, a plus b squared, is the same as a squared plus 2ab plus b squared. Or if we have one that we're subtracting, a minus b squared, it's a binomial, there's two terms, and we're squaring it. If it's subtracted, the only difference is it becomes a squared minus 2ab plus b squared. Again, both of these are just shortcut methods to the FOIL method. So if we memorize that, we can use that application here in this example. X plus 6 squared, we can say is the same as a squared, or x squared, plus 2ab, or 2x times 6, plus b squared, and in this case b is 6. And that leaves us with x squared plus 12x plus 36. And a few more examples here using the a squared minus 2ab plus b squared with different variables and different numbers. To multiply any two polynomials, vertical multiplication can also be used, just like you would when you set up your original old school multiplication problem. So in this case, we can put our larger trinomial up top and our binomial on the bottom, and then we can multiply negative 1 times the values 2w squared plus 7w plus 3. And then we can also multiply w times 2w squared plus 7w plus 3. And then add the terms in each column. So you're going vertically, negative 7 plus 3, negative 2 plus 7, and then 2 plus 0, keeping the terms lined up. So this is just another way that you can multiply polynomials using the vertical multiplication method. To multiply any two polynomials, you can also use the distributive property method. This is one that I prefer, to take each term and multiply it inside the other parenthesis to get 3 answers, and then take the next term, multiply it, but every term inside the parentheses, get another set of 3 answers, and then you can add and combine your terms that are alike together to simplify and get one final answer. Section 4.6 on dividing polynomials. You can divide each term of the polynomial by the monomial. When dividing variables, use the property a to the x power divided by x to the a power over x to the b power. Remember, we're subtracting our exponents, a minus b. So here's an example where we're dividing. And in this case, we are taking and breaking apart our fractions here into 3 separate parts. So 10 over 5 would be our first section, 35 divided by 5 is our second, and 5 divided by 5 is our third. And in that case, we can simplify these down in an easier method, just dividing 10 divided by 5 to give us 2, 75 divided by 5 to give us 7, 5 divided by 5 to give us 1, and then with our exponents we will subtract 4 minus 2, 3 minus 1, and 2 minus 2. Since these are the same, our value is 1. Any number divided by itself is going to be equal to 1. Okay, just a few left. Dividing a polynomial by a binomial. Here are some steps that we will go through. There are 2 slides. Place the terms of the polynomial and binomial in descending order. The largest to smallest. Insert a 0 for any missing term. So if there's no x squared and you're going x cubed, x squared, x to the first power, you would insert a 0 for that missing x squared term. Divide the first term of the polynomial by the first term of the binomial. The result is the first term of the answer. Multiply the first term of the answer by the binomial and subtract the result from the first 2 terms of the polynomial. Bring down the next term to obtain a new polynomial. Step 4. Divide the new polynomial by the binomial using the process described in Step 2. 5. Continue dividing, multiplying, and subtracting until the degree of the remainder is less than the degree of the binomial divisor. And 6. Write the remainder as the numerator of the fraction that has the binomial divisor as its denominator. Here is an example. Divide c squared plus 3c minus 2 divided by c plus 1. So we can set this up as a quotient with a divisor, placing c squared plus 3c minus 2 inside of our dividing box and c plus 1 on the outside. So we can multiply the first term of the answer by the binomial. C times c plus 1 would give us c squared plus c. Then we can subtract c squared minus c squared would be equal to 0. 3c minus 1c equals 2. And we can subtract the result from the first 2 terms of the polynomial and divide the first term of the polynomial by the first term of the binomial. C squared divided by c equals c in this case. And c squared plus 3c minus c squared plus c equals 2c here. With this continued, we can bring down our negative 2 like we would with regular division and ask, how can we get c plus 1 to equal 2c minus 2? Well, if we multiply it by 2, we'd have 2c plus 2. And if we add those together, 2c minus 2c equals 0, and a negative 2 minus 2 would equal negative 4 as our remainder. So we can write the remainder as a numerator of a fraction, just like we would in regular division, over what we're dividing by, c plus 1. So it would be negative 4 over c plus 1. And then here's just one more example, going through those same steps of division and breaking it down to find a remainder or no remainder. In this case, this example has no remainder, so our final answer would be y minus 3, and we can replace that in and check and make sure that our answer does make sense. Does y minus 2 times y minus 3 equal y squared plus 5y plus 6? And yes, it does.